So the first thing is how we spot that we have problems. Of course, the first and most obvious answer is by customer support. Most likely you will notice that you have problems by thousands of people coming to your support and complaining. But most likely at this point, that's already late. So we want to avoid this situation, and of course for this we start with the metrics. There are three typical kind of metrics: utilization, saturation, and errors, and they can be applied both to hardware resources and software resources. Another important thing is that saying all those beautiful ambiguous words such as everything is slow, nothing is working, okay, it's fine, maybe it gives you some relief, emotional, but it doesn't drive you to any conclusions. So it's crucial to quantify performance, to give more concrete numbers, to give more concrete metrics, and usually we use latency, elapsed time, and throughput for this. And of course there are many more, but this is the basic. Well, my name is Alina. I'm a software engineer, SRE engineer, and security champion at JetBrains. And I'm not a mobile developer. So today, I mostly try to give you not mobile only, but rather a bit more high-level system overview on the metric collection, because I believe that despite the measuring each separate component is important, but on the other hand, observing the system in general is also crucial. And I'll try to share some personal stories and maybe some experiences, best practices, what we encountered. So basically this talk is a kind of language agnostic or device agnostic. It's mostly about the approach, how you can tackle those issues and handle these tasks. And the major inspiration for this talk was in the spring when I was working for a product team. At a certain point, they noticed a huge performance degradation. And it wasn't clear at all where it comes from. We just observed thousands of users come into a support team and complaining why everything's so slow, nothing is working, everything is freezing. And when we started investigating this issue from the perspective of performance, we realized that we actually don't have enough information to do this, and we have problems now. So how we can quickly set up all the observability process, how we can make it more efficient, more quick. If we don't have huge resources, if we don't have a big team, we don't have enough time. So as always, it should have been done yesterday. So let's begin the talk. So when we talk about the performance evaluation in general, the first thing that I always try to keep in mind is that we are not actually observing the system health. Okay, we are looking at the throughput or latency, but it's not about system, it's about the user. So first of all, we want to emphasize with the user, we want to see exactly how user perceives our system, what is the user experience, how good is it? And for us, that's the most crucial thing. So all the approaches today will be user-centric ones. The second important goal in this is to reduce load on the team, because as always, everyone are very busy and we don't have enough resources always. So we need to do it as efficient as possible. And of course, if we're talking about business here, we can't avoid speaking about money. So also it's out of our major goals is to optimize cost, not to spend a huge amount of money on this. And here's a brief structure of today's talk. So first of all, we're going to talk about how we identify problems. Then we're going to talk about perceived performance from the server side of things. Then from the client, which includes both web and mobile. Then on the factors which impact performance indirectly. Then we briefly touch the point of alerts, on-call, duties, all those kind of things. And then I will try to wrap up with good practices that we encountered in our own experience. So before we talk about the actual metrics and performance, it's important to talk about the tools. So here's a brief overview which tools can be used. And of course, I'm here not to sell you anything, so I always encourage to do your own research to find the tool that is most suitable for your particular needs. Out of general notes, usually third-party applications allow you to do everything super quickly because you just attach it to your applications and it does all the work for you. But out of the downsides, of course, that would be crazy costs. You're going to spend a real fortune on this. And it also requires minimal effort, on the other hand. On the other hand, we also have the open source tools or your own tools. Here, you save money significantly, but you pay for this with the resources, knowledge sharing, people who are going to maintain this, who are going to develop it. It's more complicated in development and coverage, so it's important to keep the balance. And how to keep the balance, we're going to talk later. So the first thing is how we spot that we have problems. Of course, the first and most obvious answer is by customer support. When you have a production application and you already have it running, then most likely you will notice that you have problems by thousands of people coming to your support and complaining. But most likely at this point, that's already late. So we want to avoid this situation, and of course for this we start with the metrics. There are three typical kind of metrics: utilization, saturation, and errors, and they can be applied both to hardware resources and software resources. Here I just dropped several slides of such resources. So for example, we can count the utilization of the thread pool by the number of threads currently executing tasks, and saturation of the logs is the number of threads currently waiting for the logs. And you can apply it to basically everything. Another important thing is that saying all those beautiful ambiguous words such as everything is slow, nothing is working, okay, it's fine, maybe it gives you some relief, emotional, but it doesn't drive you to any conclusions. So it's crucial to quantify performance, to give more concrete numbers, to give more concrete metrics, and usually we use latency, elapsed time, and throughput for this. And of course there are many more, but this is the basic. And here's like a basic example how we can present the initial system state. Again, doesn't matter which system, but the key highlight that I want to mention here is that we're starting like top down, so starting from the system layer and going up and up towards the application and application grained level of application at the end. So yes, here's the overview of the system metrics. So you observe, like here as an example, the RAM memory, CPUs, disk usage. And then after we've done this, we can move towards the perceived performance of the application itself. And in my mind, this point is the most important one, since that's exactly how users perceive our application. So that's a key feature that we would like to focus to actually understand how users see our product. I'll give you a brief example. So here we're going to talk about the dimensionality of metrics. And let's say you have a big system which already contains of the classical application with backend and frontend. Also, it has third-party apps which are using it by API. And also you have mobile app. And you need to somehow track everything in this application. So it contains multiple subsystems. It's really big, so it's no point of measuring performance of it like as a whole system. It contains like very multiple subsystems. Also, it can be accessed by a UI and API. Then it has a permission scheme. So we have different type of users, from admins to guests, and it also has embedded DB. So how we define metrics for such system? And if we talk about dimensionality here, first of all, we want to focus on the first quality of the system. So that is big, basically. And we state a hypothesis that different subsystems experience different load. Okay, so we can start with the definition of the metrics buckets. Let's say it's a task management system, which is used mostly for tracking the tasks. So let's consider task endpoint. We define a metric bucket for that. Then we validate the second hypothesis. We think that the requests made from the mobile app by users, they are most likely heavier than API requests as the query is longer. How would we know this? Well, it's obvious because we designed our applications. We designed our front end, we designed our mobile. So most likely we know which query we're requesting. So based on this hypothesis, we subsplit the main bucket into two more, one for like mobile query, another one for any other queries. And if we want to track specific mobile perceived performance, then we're going to focus on the first bucket. We move on further to the hypothesis about the wide permission scheme. And we state the hypothesis as the following. So requests made by a certain team, let's say admins, they are heavier than the ones made by guests, as they have more permissions. So they can view significantly more data in the same request query. Also, I split it in by the request type because it's more convenient. And at the end, we receive the following dimensions and metrics per which we are able to track the performance more specifically depending on our needs. So embedded database is not that significant in this case because, well, it should be benchmarked separately. So we can avoid it at this stage. We can define metrics like directly in the code using custom metrics, for example, again, as a third-party app. If we just attached a third-party tracker like New Relic, for example, or Sentry, it's probably going to eat a lot of money because you don't control the data ingest. I personally prefer to set custom metrics because then you manually control everything you ingest, and it saves you like a lot of money because I think in our case it was 20 times less when we switch to the custom metrics. And here's the example how it could look by subsystem. You analyze, like here's an example of RP requests per second, but it could be basically anything, that doesn't matter. And if we take a closer look, so here are our dimensions. So I want to see a certain metric for a certain subsystem, for a certain request type, for a certain query, by a certain parameter. And it gives us a very clear understanding of what we're having for specific users and specific applications. And let's move towards the front-end monitoring, because that one was mostly focused on just the general concept. So for the web front-end, we have the commonly known Web Vitals produced by Google. And I'm pretty sure that a lot of you already know them. The interesting point about them that I would like to mention is that now more and more applications are switching towards the single-page app. And for single-page apps, which can also be a progressive web app, if you want them to be so, it's kind of still very hard to track the Web Vitals since when they were designed, they weren't designed with SPA in mind. So they mostly focused on the actual switches between the pages, while SPA is well known for the dynamic rendering of the content. So you don't actually reload the whole page. And it gives us a number of difficulties. So, of course, single-page app is better in terms of user experience and dynamic UI updates. But at the same time, you pay for this with a longer initial page load time. And of course, you can aim to reduce it as well, but still, generally speaking, like on average, it would be higher. And all those small dynamic updates won't be taken into account when they will be calculating your Web Vitals. The second part is that it provides improved performance due to caching and lazy load, but at the same time, you pay for this with the problems with the search engines because they rely solely on the Web Vitals, and Web Vitals might not be always accurate for your SPA. Also, it provides a reduced server load, but at the same time requires more development team effort. And yes, that's my major problem here is that it's measured based on the current top-level page navigation, and all this up, soft navigations won't be considered. So how we can tackle this? If you have a single-page application, you track a separate set of performance metric. So for this, it should be, for sure, dynamic page updates. So you should consider all those soft navigations points. Also, XML, HTML request data, performance data and throughput for the page loads, and route changes exactly about soft navigation, and also sync and async JavaScript activity. And while Google is aware about the thing with Web Vitals and that more and more teams are now opting for the single-page application, they now ran a pack of experiments to actually support such applications for the Web Vitals. They're not yet like fully completed, but they can be turned on under the experimental feature flag, and you can try them to see how actually your metrics could improve with this flag. But still, this work is not finished yet, so it's from my experience at least, that was the most common mistake when people were tracking performance for general like web front-end applications, and they weren't taken into account that it was actually the single-page application, and they received much worse results than they should have actually received. Okay, here's just an example how that could look in terms of the dashboards. And let's switch towards the mobile metrics monitoring. So for mobile, we also have vitals by Google, and two core vitals, which are the user-perceived crash rate and user-perceived application not responding rate. Those two are like the two core metrics which should be tracked in any way. Here I also written down four metrics that we personally, in our experience, find extremely useful out of other vitals that can be listed on the official resources. So the first two basically dedicated to the app startup time, and they both are equally important because the first one gives us the sense that something is going on in the app, that it started loading, and the second one is that it's actually loaded. Then UI responsiveness, well, also similar in terms of the concept to the web vitals, and UI stability, of course, or if anything is flickering on the screen. But what are the most common problems when trying to track those metrics? Well, first of all, if you're talking about the benchmarking, yes, okay, we have micro benchmarking and micro benchmarking, ideally embedded into CI/CD pipeline, like for example GitHub Actions. But the trickiest thing is that it's widely considered a best practice to use it on the real device instead of emulation, because yeah, you can do the benchmarking on various types of emulated devices, but it's definitely not going to be as accurate as it could have been. And we also ran into this problem because we actually didn't want to have a farm with people like actually trying to run it on the physical devices. So from what I've seen in our cases, the most reasonable solution was to opt for the services that provide this, like Firebase, and do it only for the most critical parts of the application. Like again, we did the clusterization and defined our dimensioned metrics, as I showed you before, and then like for the top 5, we preferred the physical device over the emulation. The next point is indirect monitoring, indirect performance monitoring, and we're gonna do this on the example of the concurrent applications. So as an example, I decided to talk about the thread pool and thread pools executor. So the concept of thread pools is pretty straightforward. You have a fixed thread pool with a size equal to the number of threads. Then you have a certain queue of tasks, and then each thread is taken the task and executes it and returns to the pool. So here's an example of the formula, which is one of the many formulas that can be used to determine the initial size of the pool. Of course, it's not a silver bullet, it should be adjusted experimentally. But the most important thing for us in performance tuning here is the size of the thread pools. So let's say we have 2 thread pools executors. We have applications that sends all the tasks there. We have 2 respective queues for tasks. And then we have thread pools from which threads are taking those tasks. Moreover, we have an additional thread pool which can put additional threads if the capacity of the current pools are not sufficient to actually cover all the tasks needed. And how we can actually formulate the performance monitoring here? Well, pretty simple. We define the monitoring for the maximal pool size, then for the current pool size. And here on this graph, you can see how exactly the capacity was adjusted based on the needs of our applications. And of course, if there are like too many tasks in a queue waiting for the thread to pick it up, it's obviously a great indicator for us that things are not doing great. Yes, so here you can observe the completed jobs and the failed jobs and the max running time. So on those picks, it's quite clear where things went a bit worse. And let's talk about alerts. Is there anyone here who ever been on call? Raise your hand. Okay. Yes, great. So probably then you would feel what I'm saying about the pain of being on call. So basically, the major quality of on-call engineer is being able to react fast on the incidents that happen. And if you have a lot of clients, the number of alerts could be incredible. So the most difficult thing of being an incident response manager is that your capacity is limited. You know, like we are all humans, and if you're overloaded with a huge amount of important alerts which require action, you physically wouldn't take more than a certain amount of them. So like your capacity is not unlimited. So it's important to reduce cognitive load as much as possible to make the number of alerts as little as possible for the on-call engineer. We kind of use the most obvious framework for this, and I kind of like it because sometimes the simplest things are the best. So if something is urgent and it requires human intervention, then it should be an alert. If it's not urgent, just create a ticket. If it doesn't require the human intervention, then use automation, doesn't matter if it's urgent or not. And yeah, as I said, the number of alerts shouldn't exceed your cognitive capacity, because otherwise you just stop paying attention to them if it's going to be too much. And one of those examples of the automation for the urgent alerts was the cloud balancing. So before all the changes, we used to have an on-call engineer who would react to alerts such as like low disk space on host or high CPU usage. And more or less, every time it was the same routine work. You just check which host is free, move application there, and you're good to go. We just implemented the cloud balancing algorithm, which would do the very same thing for you. So it's just an example of nicely worked automation. But of course, you pay for this with engineering effort spent on this automation. And let's gradually move to the good practices that we encountered. The first and the most important one is post-mortem evaluation. So it's not a secret, almost in every product there was at least one case when outage occurred, or I don't know, everything was frozen for a long period of time. So incidents are normal. And of course, it doesn't mean that we shouldn't fight against them. Of course, we should aim for the higher availability and all those kind of things. But again, it's possible that it's going to happen. So we just try to analyze post-mortems and every time improve our metrics, evaluation, aggregation. We always check what data were we missing, what data wasn't sufficient to solve the problem faster. And by continuous improvements of the metrics process, we can handle incidents faster and faster every next time. I would say that should have been actually the top one thing, even higher than post-mortem evaluation, knowledge sharing. If you have a separate support team, customer support team, SRE team, development teams, all of those people should be in the same context regarding the incident management. For us, what worked, we kind of set up weekly meetings where we shared all the knowledge, all the recent updates, and every time we try to do it as fast as possible, because every piece of knowledge contributes to your speed and how fast you resolve the next incident. Another crucial thing is that the process of adding new instrumentation should be simple, because again, it's a continuous process and you constantly need to adapt something. For the dashboard part, we prefer an approach from zoom in, zoom out, basically meaning that you start with a general system overview and then drill down towards the most segmented parts of your application. And the last point that helped us to bridge the gap between all the development teams and management is that we created separate types of dashboards. Once were purely technical, purely dedicated to our own convenience, and others were a bit more high level with included SLAs, SLOs on them. And when the management team wasn't unsure how much resources we need, or like why we again complaining about the performance and that we think we should invest more time in this, we just show them these graphs, and it kind of makes it easier for each of us to understand each other. And to wrap up this session, I would like to kind of answer the question that I asked in the very beginning, how we actually can collect application metrics if it needed to be done yesterday. And well, the most honest answer would be we can't. It's no way we could do this. But again, if you take everything I mentioned before, it gives you a solid foundation. So it provides you with a good enough coverage, which can be then fine-tuned further, which can be improved further. But with all of that, you already can start actually bringing value to your performance process. And even this would be sufficient to track the most critical issues. Of course, it's very application specific. Of course, it needs to be fine-tuned every time after every incident. But this provides you a decent base to set up the whole process all in once. Thank you.
Thank you, Alina. Thank you so much.
Thank you.
Thank you so much. That was very insightful. I really felt the part about the on-call, being on-call.
Thank you.
Do we have any question from the room?